Hello, welcome back to another episode of Tronics in 10. Well, it's been a while since I've uploaded any videos, late January to be exact. I apologize for the delay. I got busy with my daytime job and I waited until I got a high definition video camera. So everything from now going forth will be in 720p high definition, and the circuit board looks a whole lot clearer than previous videos. And I've also shaved off my beard, so I look a whole lot clearer as well. In part 5 of the BC-1 radio series, I mentioned to you that we would be building an AGC circuit to add on to the radio. Any simple radio receiver has a downfall in that the volume level varies considerably between weak and strong stations. Well, by the use of an AGC circuit, we can control the gain automatically so the volume does not vary too much between a strong and weak station, and therefore you will not have to constantly to turn the volume up and down to compensate, because the circuit will do it for you automatically. So we're going to get started with part 1 of probably 2, maybe 3-part series on building the AGC circuit. So stick around, we'll be right back right after this. Now, if you've been following along while we were building the BC-1 radio, we left off in part 5 with finishing the audio output amplifier, and we had the green alligator clip that connected to this output capacitor that fed audio into our amplified computer speakers. Well, I've added a few things since part 5 of the video was completed. I've added an extra copper circuit board strip which will be used to pick off our VCC plus operating voltage from the 9-volt bus. I have a decoupling resistor, which is 33 ohms. It's orange, black is the color code, and it picks off 9 volts from this distribution strip that is used to feed power to the RF amplifier that drives the audio detector diode. And the 33 ohm resistor then feeds power to this strip, and I have it bypassed with a 0.022 mic capacitor for the high frequency bypassing. And then I have a 4.7 mic electrolytic capacitor to ground to bypass the lower frequency components. So basically what we're going to do to obtain our AGC control voltage is the output of our detector diode. There's 2 components. There's the audio portion of the signal, which we pick off with a 4.7K resistor, and then we have a 0.02 microfarad capacitor to ground that filters off the RF. And then audio is coupled to the audio amplifier stage by way of this coupling capacitor. The other item that is present on the cathode end of this diode is a DC voltage that varies along with the intensity of the received signal, which is going to vary as you go from one station to the next. We're going to pick off a sample of that DC voltage, and we're going to use it to drive a 2-transistor AGC stage, which will be used to control the gain of our audio output stage. So, the first thing that we're going to do is we're going to solder a 100K ohm resistor. Color code is brown, black, yellow, and we're going to solder that to the cathode of the detector diode, which we will do just like this, and get my board to stand still. Okay, then we're going to connect the other end of the 100K resistor to a capacitor, which is 0.47 microfarads, and that capacitor is going to go to ground, and the other end will connect to this resistor. So we'll get that soldered down. Now the purpose of this resistor and capacitor, it forms an RC network, and the combination of the two filters out the audio component and also the RF component, so that all we have left is essentially a DC voltage that varies along with the received signal strength. And it is here that we're going to feed it to our first transistor stage by way of a potentiometer, so that we have a way to adjust the threshold at which the circuit activates. Okay, the next item that we're going to install, this is a 50K potentiometer, 50,000 ohms, and like we did with our active components, I have mounted this on a perf board, and I've extended the leads out to make it easier to use it in the circuit. I keep the two halves of the perf board together using wire ties on each end to hold the two boards together. And if you're just joining my videos, I have older videos that show how to prep circuit boards, and it'll show you how to make these perf board component modules, which makes it a whole lot easier to build your projects. We're going to mount this on the circuit board, and I'm going to solder down one of the tie wraps that hold the two pieces of perf board together, so this thing doesn't slide all over the place. and the wiper of the potentiometer, the center pin, that lead comes out and will connect to the junction of the 100K resistor and the .47 mic cap that we just put together. Okay, and then the other tie wrap end of this potentiometer module, I'm going to solder that down so it makes everything nice and rigid and it doesn't move around when you turn the potentiometer back and forth. Now, one end of this potentiometer goes to ground. That's one of the outside connections of the potentiometer. That goes to ground. So we'll solder that down on the same solder pad that we soldered the wire wrap of the perf board to hold it in place. So now we got one outside leg of our potentiometer, 50,000 ohm, connected to ground. Okay, and then on the other end of this potentiometer is where we're going to hook up our first transistor stage. This is an NPN transistor, 2N3904 variety, just a general purpose transistor. The pinout for this particular transistor that I have, with the flat side facing you, left to right, it's going to be emitter-based collector. And since this transistor stage is being used as switching, just a DC switching stage, the emitter is going to be grounded. So we're going to solder that down to ground right now. Again, the emitter lead of the transistor goes directly to ground. Now you can see why I added an extra VCC voltage strip, because it provides a convenient pickoff point. We're going to have a 10K load resistor connected from the collector lead of the transistor, and that's going to go down and pick up 9 volts off this circuit board trace that we cut and placed. But right now we're going to take the base connection of the transistor and we're going to hook that up to the other outside connection on the potentiometer, and I'm going to twist these together for good electrical contact, and then I'm going to put a little bit of solder on it and then cut off the excess. Well, we're out of time with this episode of Tronics in 10. We'll pick up where we left off in part 2, so stay tuned for that. Thank you for watching Tronics in 10. My name is Brian, and I hope you have a good time building projects on your workbench. Bye-bye.